Good morning, students. So in this video lecture we can see the experiments which are conducted in our thermal engineering lab. So that is 18 MPC 507 thermal engineering lab 1. Okay. So here we are going to see about this Mitsubishi engine, that is the performance test of Mitsubishi engine. Okay. So the performance test on this Mitsubishi engine is, the aim is to conduct a performance test on Mitsubishi engine and to draw the performance characteristic curves. So what are the apparatus that are required? So this Mitsubishi engine, which is a horizontal engine which runs at around 2200 rpm, that is a rated speed, which has a loading rope brake setup and a measuring tape, then stopwatch, tachometer, spring balance and a bucket. So all these are needed so for finding the performance characteristics of this Mitsubishi engine. Okay, this is the specification of the engine, where I told you that the rated speed is 2200 rpm and the rated brake horsepower is 9 and the bore and the stroke is 92 and 95 mm. And the fuel used is high speed diesel. The type of engine is a single cylinder 4-stroke horizontal diesel engine, and the coolant here we are using is water coolant. The type of loading is rope brake loading. So the formulas, we can see the formulas. So that is, the first one is the maximum load current, so which is used by the formula, that is BHP into 4500 divided by 2 pi n into R effective. So this BHP is the rated BHP and n is the speed, and the effective radius is the sum of the brake circle. If you find the circumference of the brake drum, so you can find capital R, and if you find the circumference of the rope, you can find the small r. So if you add these two, you will get the effective radius. Okay, and brake power is given by this formula, that is 2 pi n R effective into W1 minus W2 into 9.81 by 60 into 1000. So this W1 and W2 are, so initially we can see that in during the experimentation we can see, so it has a dead weight of around 1.5 kg. So if you add this weight around 1, 2 and all, so you have to add this, so 1 plus 1.5, that is 2.5, and you have to subtract with that dead weight, that is 1.5 kg. So that is W1 difference, W2. And the total fuel consumption is given by VCC, that is how much of fuel is taken for the consumption of that engine, and that is here I think we are taking 25 cc of fuel consumption into specific gravity of fuel into 3600 by 60 into 1000, and the indicated power is given by the formula, the sum of brake power and the friction power, and the heat input is TFC, that is total fuel consumption, into 108.33 into 427 by 4500. The mechanical efficiency is brake power by indicated power into 100. And when you go for volumetric efficiency, it is VA divided by VT into 100, and brake thermal efficiency is BP divided by this heat input into 100, and the air fuel ratio is WA by WF. So these are the formulas which are meant for this performance characteristics, measurement of the performance characteristics. And now we can go for the experimentation. So in experimentation I will show you how we can measure the what is the fuel, how much the fuel is consumed, and what is how we can measure the speed with the help of tachometer, and how this what is that fuel consumption. So how we have to measure the time with the help of stopwatch. So all this can be seen through this experimentation. So this is this engine is called as Mitsubishi engine. So it is a horizontal engine. So you can see here in our thermal lab, so most of the engines are vertical engine, and this is the engine which is a horizontal engine. So here, so we can see that the number of cylinders is 1 and the number of strokes 4, and now type of fuel that is used is high speed diesel, so which has a higher calorific value. So then that is around 43,350 kilojoule per kilogram, and power is 9 brake horse BHP, and the speed is 2200 rpm. So the shaft is made in such a way we can measure the speed only about half of it, so that when you measure with the help of the tachometer, so you can see, so when you measure the speed with the help of tachometer, you can see here, so you will get around 1100 rpm. So the rated speed is 2200 rpm, half of it is 1100 rpm. So when you have 1100 rpm at this place, when you measure the speed with the help of tachometer, so easily you can say that the rate you have achieved that rated speed. So then after what you have to do initially, so you have to this is for the measuring the rated speed, and then you have to measure the circumference of the brake drum, and then you have to measure the circumference of the rope, so that if you find the value of the radius of both this, so if you take the circumference as 2 pi capital R is equal to some value of this, and similarly 2 pi small r as the value of this, so if you find the value of capital R and small r and add it, you will get the effective radius. So this is for measuring the circumference of this brake drum and the rope. Then what you are going to do, so this is the dead weight of that engine, that is around 1.5 kilogram. So whatever, if you add some weight on it, so 1.5 to 2.5, so you have to subtract this 1.5 kilogram. So then, so if you want to measure the fuel flow rate, suppose if you add initially you will not add load, so if you add load, you have to measure the fuel, how much of fuel is sent to the engine can be measured by this beaker. So you can see here, so you have so this gives you 25 cc of fuel consumption. So when the fuel reaches from this place to this place, so you have a marking here, so you have a marking, so the fuel consumption is, now you can say that it is 25 cc. You have to measure the time for that 25 cc of fuel consumption. So initially when you start this engine, so you can see here, so you have markings as stop, start and run. So you can see here, stop, start and run. So when you want to start the engine, so you rotate it and you push this towards the start position, and then when you move this, so you can make it to run. So initially you have to measure the speed without adding any load. So already I told you that there is a dead weight load which is around 1.5 kilogram. So whenever any other load is added to this engine, so you have to subtract with that. So initially you start the engine, then after that you know that whether you have to measure the speed with the help of tachometer. That is around 1100 rpm. That means, so you can see here, so this is tachometer. So with the help of this tachometer, so you can see that when it is around 1100 rpm, so you can confirm that it is the engine is running at the rated speed, that is 2200 rpm. Okay, so you start the engine, and after that what you are going to do, so you are going to measure the fuel consumption. So initially, so you measure the fuel consumption with the help of the fuel supply that is going to the engine. So you can see that, so this is the knob, so this is the knob. So when you make this knob downwards, so parallel to this pipe, this flexible hose or a pipe, so that means the fuel flows to the engine. So when you cut off, the fuel directly goes from this fuel tank to the engine. So if you make it on, so you can see that how much of fuel is going to the engine through this measuring jar. So you can see that it is around 20, this is around 25 cc. So you are going to measure the time for this 25 cc of fuel consumption. So with the help of all this, so you can do this experiment. So you can see that with the help of this stopwatch, so you can measure the time for that 25 cc of fuel consumption. So you can measure the fuel with how much of time is taken for this. So with the help of all this, so you can go for the calculation part. Okay, so from the calculation part we can see how we can measure the performance. So what are the performance parameters? So that we have to measure with the help of the data that were gathered from this Mitsubishi engine. So, thermal efficiency, mechanical efficiency, indicated power, brake power, then total fuel consumption and specific fuel consumption. So, these comes under the performance parameters, and you are going to measure you are going to find all these performance parameters with the data which you have measured in this Mitsubishi engine. Now, you can see that the maximum load current is given by the formula. Already we have seen this formula, so we can easily substitute all the values which you have measured, and you will get the maximum load current. Okay, so that is around 18.06 Newton. And brake power, the formula is given to you. So here we are considering for 4.5 kilogram minus this 1 into 9.87, so you will get this value, so which is equal to 1.283 kilowatt. Okay, and the total fuel consumption is given. So as I told you, it is 25 cc of fuel consumption, and the specific gravity of the fuel is taken as 0.83 and divided by 60 into 1000, so you will get the value of around 0.71 kilogram per hour. That is the total fuel consumption. When you go for indicated power, it is the sum of brake power and the frictional power. So already we know these two, so you can easily find the value of indicated power. And when you go for heat input, we know the formula. TFC is already known to us. So substitute the value in the formula, so you will get the value of heat input. And mechanical efficiency is given by brake power by indicated power. So these two are known to us. And the percentage of mechanical efficiency is around 25.75 percentage. And when you go for volumetric efficiency, these two are obtained with the help of the readings which we have taken, that is 26.93 by 41.68 into 100, you will get around 61.61 percentage volumetric. And similarly for brake thermal efficiency also, so you use the same formula, that is the brake thermal efficiency is BP by heat input, so which we have seen in the formula section. So divided by this heat input, you will get the value which is around 17.61 percentage. And the air fuel ratio is also given by rho A. WA is rho A VA divided by WFC is WF is TFC into 9.81. So you will get the value. So all these things are known to us. So density and this volume, and then the value of TFC is known to us. So you can, TFC means total fuel consumption. So everything is known to us, and you can find the value of air fuel ratio. So all these has to be substituted in a tabulation, and you form the respective tabulation with the actual volume of air intake, that is VC, and then volumetric efficiency, weight of air intake, then air fuel ratio, TFC, BHP, then frictional power, indicated power, mechanical efficiency, and brake thermal efficiency. So all these, so the calculation was shown for a single reading. So you have to consider for all the 5. So you have to work out for all the 5, and you have to substitute in the tabulation. And when you go for graphical representation, you can see that you have to draw graph between this brake power and this TFC, total fuel consumption. So you can see here, so you will get a line like this when you draw graph between these two based on this tabulation, that is brake power and the frictional power. So when you draw the graph between these two, you can see here, so you got a thick continuous line like this, a straight line, a straight inclined line. So when you extend that and to meet this zero line, so you can see that it will meet at some point on this. So that is that side is nothing but the frictional power. It is not negative, because when we know that the power which is available at the shaft is brake power. So if you are applying load on it, it has to act in the opposite direction. So similarly, if brake power is in the positive quadrant and friction power will be in the negative quadrant. Okay, so but the value you have to consider only the magnitude. Okay, so the friction power, you can see, we can find the value of the friction power when you draw a graph between TFC and the BP. And similarly, when you draw a graph between brake thermal efficiency and the brake power, so you will get a curve like this. So an increasing curve, and it will at certain stage it goes to the maximum, and after that it declines. Okay, so similarly for mechanical efficiency versus brake power, so you will get the same type of curve. And brake power versus volumetric efficiency, inclined straight line, so you will get a line like this. So when you substitute all the values, so these are the performance parameters, and the respective graphs were also drawn. So from the performance parameters, so we can see that our aim is to determine the frictional power. So this is around 3.7 kilowatt. Okay, so with the help of this Mitsubishi engine, so we know the what are the performance characteristics and what are the graphs which we have to draw based on the data that were obtained during experimentation, and those experimentation values were tabulated, and then we have drawn a graph between all those. Okay, so with this the performance test of Mitsubishi engine, it comes to an end.